All right, in this tutorial, I'm going to show you how to make a smooth movement with the turtle. By smooth, I mean it doesn't move in a choppy grid. It moves kind of continuously, and it can go anywhere that you want. So um, first thing I'm going to do is I'm going to take this sprite and I'm going to save it as an object. Make a const turtle, and then here I'll add the drawing. That'll let me manipulate this turtle more. The turtle has a bunch of things that you can change about it. Most usefully, oops, I put a semicolon there. Most usefully, turtle has a property update, which is a function that runs once per frame that it's animating. And that's familiar to you from the earlier animation we've done in class. It gets information such as the step time, which is how long it's been since the last animation. It also gets the context and all kinds of other things. But for our purpose, really all we need is the step time. All right. So if we want the turtle to move smoothly, the simplest way to think about it is to store the turtle's velocity. Now, velocity is speed. If you've taken physics, you might have heard of the idea of a vector. What that means is that, let's say the turtle's moving this way, up and to the right. You could think of that as like the hypotenuse of a triangle, right? It's moving a certain amount up and a certain amount over. So the vector has what we call a y component, how much up am I moving, and an x component, how far over am I moving. And then the result of that is the addition of both of those items. So that's how we talk about vectors in physics and in game graphics. I'm going to use Vx for velocity in the x direction as my variable. I'll start with it at 10 just so we can see something happening. And I'll use Vy, and maybe I'll start with it at 5. It's nice to make it different so we can make sure that we see a difference. Okay, all I've done right now is create two properties of the turtle, Vx and Vy. They don't do anything. Now in the update function, I can make them do something. So the turtle is drawn at whatever its x and y coordinates are. So if I want to see the y value change, I would need to say turtle.y plus equals, and now I have to add to it. Now what am I going to add to it? So you could just add turtle Vy. You should see the turtle fly off the screen quite quickly now. There he goes flying. That's moving much faster than 5 pixels a second. And that's because this function is running as fast as the computer can animate. It depends on the speed of the browser, but probably somewhere around 60 times a second. So I want to multiply that by step time over 1,000, which would give me this Vy is in pixels per second. So now, regardless of how fast the computer is, it will always move down at exactly 5 pixels per second. To do the Vx is going to look exactly the same. Turtle.x plus equals turtle.vx times step time over 1,000. Now I should see the turtle moving more quickly to the right. Very nice. And over. So that's pretty good. If you don't like the fact the turtle looks like he's skidding across on his own power, it might help to rotate him. The sprite has a thing called an angle. So I'll show you how that works up here first. So for example, if I said turtle angle equals math.pi, that would flip the turtle over 180 degrees, which is pi radians. If you haven't taken trigonometry, you'll just, sorry, you'll have to trust me on this. So this requires a little bit of trig. The correct angle can also be determined based on the Vy and Vx. So turtle.angle should be equal to the arctangent. Tangent is from SOHCAHTOA. tangent is opposite over adjacent. So the angle here is the y and the x, so the opposite is the y, so turtle.vy, the adjacent is the x, turtle.vx. So that's pretty good. The problem is that the reference angle is 0, which is going straight to the right. And as you might recall, our turtle began in facing straight up. So I might make a start angle variable, which shows the fact that the turtle began straight up. And then we could do the angle equals turtle start angle plus math a tan. Oh, straight up, sorry, it was only a quarter turn, not a full turn. There we go. And if I change these values, I should see the turtle's movement and his rotation change to reflect the new values. So that works pretty well. Next step would be to hook up some keyboard controls. And it's up to you how you want to think about that. Keyboard controls could change acceleration, they could change speed, or they could set speed in an absolute manner. So I'll show you all 4 of those options. Add handler is how we add anything that responds to an event. We'll deal with a keyboard for now. So we'll say key press, and then that runs a function which gets an event. So the event key is the key code, and we write these simple if statements to check for different keys. So I've got if statements for A, D, W, and S, and now this is where I could decide. So let's say I wanted to set the velocity absolutely. I could just say the turtle Vx when it's A is equal to -10, and the Vy is equal to 0. And when it's D, it's equals to 10, and the Vy is equal to 0. So let's see what that looks like. So there's A, and there's D. All right, looks like I've got a little problem in my arctangent logic I could have to look at later, but that's all right. It's basically working. So now I add a W. Oops. W. Yep. There we go. Oops, I have these backwards, huh? All right, I'll have to think about that trig later. All right, so that, the motion works. The other way I could do this is instead of setting it absolutely, I could just make the keys change the velocity. So it'll add 10 to it or subtract 10. So that would be more like accelerating. So it should say each time you press the key, you're making it go faster in that direction. And that will allow the turtle to move in all possible directions, not just in 4 directions. So let's see how that works. There he goes. Okay, come back. There he goes backwards. And we can see I haven't quite thought through my rotation logic yet. I'll have to do some thinking about that and fix that later. But that basically works. The last thing you probably want if you've got a turtle that can move in infinite directions is some kind of checking for hitting the wall. So the easiest way to do that, I usually like to break it into a separate function, and I might say something like check for wall, and then I can make turtle check for wall into a function. And here I could check, if turtle x is greater than. Now I might want to bring in the width and the height parameters are given to me by the library. So let's bring in width and height. So if it's greater than the width, and you can decide what happens if you hit the wall. So the two options are you bounce or you go through. So let's bounce. So if we want to bounce, we're going to take the x component of our velocity. We're going to multiply it by -1. That's to say we'll reverse it. And then the other important thing we want to do is we're going to set the width to be exactly the width. Otherwise, it's possible to get stuck out there and bounce back and forth and never come back. So we set a limit as well. If the turtle y is greater than height, vy times equals -1, turtle y equals height, and then we check for the 0. Times equals -1, turtle y equals 0. All right. Oops, I did the wrong value there. All right. So let's watch our turtle bounce now. There he goes. Successfully bouncing. And beautiful. Now he's moving pretty quick. All right, so I still have to figure out what's going wrong with the... Oh, what's interesting? He moves correctly when he bounces. Well, in most directions. I guess it depends. Alrighty, well there we go. That's a bouncing turtle. Forget about the rotation. I'll fix that at some point and explain it to you. But this has been over 10 minutes, so I'd better stop.